Welcome friends. Today we will learn about synchronous clocked sequential circuit. Synchronous clocked sequential circuit constitutes of both combinational circuit and as well as clocked flip-flops in the feedback path. So the output is depending on both the present input as well as the previous states of each flip-flop that is going to be available in the feedback path. So this is the clocked sequential circuit. Now we will learn about the latches before we can deal with the flip-flops. So this diagram shows the corresponding SR latch circuit with two cross-coupled NOR gates. Now we will analyze the behavior of this latch. If the input S is equal to 1 and R is equal to 0, we know that if any one input of the NOR gate is 1, the output is 0. So Q dash is 0. This 0 is fed back here as the input, second input to this NOR gate. So to produce output as 1, because both are 0 and this input is 0, so output is 1. So Q is 1. Q dash is 0. Now if S goes to 0 at this moment, what happens? So here both inputs are, this is 1, this is 0, so 1 plus 0, this is 1. Because of this NOR gate it goes to 0, and this 0, 0, 0 plus 0, 0 or 0 is 0, and the output is 1. So if when S is equal to 1, or equal to 0, Q equal to 1, Q dash is equal to 0. At this moment, if S again goes to 0, the output does not change. So that is after S is equal to 1 and R equal to 0. Similarly, when S is equal to 0 and R equal to 1, we can have the similar analysis such that Q becomes 0 and Q dash becomes 1. When at this situation, if again R goes to 0, the output does not change, so it remains 0 and 1. So that is, we have considered it as after S is equal to 0 and R is equal to 1. When both input S and R are 1, what happens? If any one input of the OR gate is 1, the output becomes 0. But this is not appropriate condition of output. What is the condition of output? Here this is Q and this is Q dash. That is, one is uncomplemented output, one is complemented output. But the situation here is both becomes 0, which we call it as indeterminate state. The corresponding analysis is done here. When both S and R are 0, 0, the previous output Q naught is 0 and the present output Q is 0, Q dash is 1. So Q is equal to Q naught. Similarly, if S is 0 and R is 0, if Q naught is 1, again the next state Q is equal to 1 and Q dash is equal to 0. That is why Q equal to Q naught. If R equal to 1, S is equal to 0. So Q becomes 0 and Q dash becomes 1. If R equal to 1 and if previously, if it is going to be that Q naught is 1, the output Q is remains 0, Q dash is 1. So Q equal to 0 in these both cases. When S is equal to 1, R equal to 0, Q remains 1, Q dash remains 0. When S is equal to 1, R equal to 0 and previous value of Q naught is 1, then at this combination also Q is 1, Q dash is 0. But when both S and R are 1, 1, whatever may be the previous value of Q, so the output is Q and Q dash becomes 0, which is indeterminate, Q equal to Q dash. So when Q equal to 0, we say that it is a reset condition. Q equal to 1, we say it as set condition. Now the same circuit with respect to same latch, SR latch with NAND gates. So we know that any one input of the NAND gate is 0, the output is 1. So in similar fashion, we analyze if S is equal to 1, R equal to 0, Q becomes 0, Q dash becomes 1. At this time when R becomes 1, that is from 0 to 1 also, there is no change in the output. Q remains 0 and Q dash is 1. When S is equal to 0 and R is equal to 1, q becomes 1 and q dash becomes 0. When at this stage, if s changes from 0 to 1 also, there is no effect, q and q dash remains the previous value. But when both s and r are equal to 0 0, now the indeterminate state comes where both and q dash tend to be 1 1, which is not allowed. So this is the function table for a SR latch implemented using a NOR gate and as well as NAND gate. Now whether is it possible to modify the corresponding SR latch behavior such that when both S and R are 0 0, if it is going to be in the NAND gate implementation, the output tends to be both q and q dash tends to be 1. So we need to avoid that. Is there any way with which we can avoid that? So we can add a control input so that we will try to avoid the indeterminate state that occurs in the previous implementation. So we have included 2 more NAND gates here, that one input of each NAND gate is given by S and R. So another input of these 2 NAND gates is driven by a clock input, a control input. As long as the control input is 0, whatever may be the input of S and R, okay, the corresponding value is not going to be arrived at this output. So we are not going to have any state changes with respect to q and q dash. So irrespective, that is, if clock input is 0, there is no effect. Whatever the previous value of q and q dash, that will remain. That is why no change. When clock input is 1, both S and R are 0, what will happen? So both the NAND gate produces the 1, because any one input of the NAND gate is 0, the output is 1. So that is this condition. When clock equal to 1, both S and R are 0 0. Whatever the previous value of q and q dash, that is going to be remaining, because this is 0, this is 0, output is 1 here, 1 here. So whatever the previous value of q and q dash, that will remain. If clock input is 1 and S is equal to 0, R equal to 1, S is equal to 0, R equal to 1, both the input of these NAND gate, that is NAND gate is 1, but output will be 0. Whenever one input of the NAND gate is 0, output is 1. So this 1 is fed back here, S and this value is 1, the output is 0. So Q becomes 0 and Q dash becomes 1. Similarly, when S is equal to 1, R equal to 0, Q becomes 1 and Q dash becomes 0. When both are 1 1, again the Q and Q dash going to be the same value, so which is indeterminate. So even though we add a clock input here, we are not going to avoid the indeterminate state in this implementation. Now what is the other way to eliminate the undesirable condition or indeterminate state of the SR latch? So both S and R should not be equal to 1 at the same time. So that is a condition. So we are going to give one input here. This you can consider it as S, and the same value is not going to be appear. That is, S and R will not be, to ensure that S and R is not same at that same time. So we are going to invert that input here and give it to this NAND gate, one input of this NAND gate. So at this time, so the same explanation here also holds good. When C is equal to 0, there is no effect. Q and Q dash will remain with the same value. When when C equal to 1, D equal to 0, Q goes to 0, Q dash is 1. When D is equal to 1, Q is equal to 1. So we will see the synthesis using T flip-flop in the next video lecture. Thank you.